Yes, as we have discussed earlier, the vector equation of a plane passing through what? 2 points. R bar is equal to 1 minus S into A bar plus SB bar plus TC bar. Today, let us discuss about the Cartesian equation of a plane passing through the 2 points A bar and B bar and parallel to the vector C bar. Let us see what is that. So let us take the figure. This is a plane passing through 2 points. Yes, this is A of A bar, B of B bar, P of general point, it's R bar, to name that as a plane equation. This is what? C bar is the vector parallel to the plane. Now, okay, whenever 2 points are given, you have to consider the what? Third point. That's a general point. So, what's the theorem it says? Cartesian equation of a plane passing through the points A of A bar, B of B bar and parallel to the vector C bar is given by the determinant is equal to 0, x minus a1, y minus a2, z minus a3. Next, AB bar, b1 minus a1, b2 minus a2, b3 minus a3, c1, c2, c3. Yes, the proof of this one is very simple. Let OA bar is equal to A bar, OB bar is equal to B bar, be the position vectors, and PB any point in the plane where OP bar is equal to R bar. Yes, from figure the vectors AB bar, AP bar and C bar are lying in same plane. Now look here, when you are having the points, when you want to prove them as coplanar, they must be coinitial vectors according to the definition of coplanarity and a plane. It may be 3 points, it may be 4 points, let it be any number of points you may take. But provided you have to construct them as a vectors. When 3 points are given, you have to construct 2 vectors. Those 2 vectors must be coinitial vectors. So therefore, what I do is, so from figure are laying in the same plane, which implies AP bar, comma, AB bar and C bar are coplanar. A coplanar. There exists scalars S comma T such that one vector can be expressed as linear combination of remaining vectors. Linear combination of remaining vectors. This is according to what? The vectors method. I want Cartesian equation method. For vector equation, you can construct in what way? Already I told. R bar is equal to 1 minus SC into A bar plus SB bar plus TC bar. This will become this only. But at present I don't want. So therefore, there is a coplanar for this. For Cartesian equation, this sentence is not necessary. You can go for directly coplanar, which implies coplanar vectors are linearly dependent. Dependent means what? Actually, box of, look here, dependent, which implies determinant of them is equal to 0 or else. So, you will come across next in the multiple product of vectors. When any three vectors are said to be coplanar, the necessary and sufficient condition for any three vectors to be coplanar is box of AP bar, AB bar, C bar is equal to 0. Box is nevertheless, it's a determinant det value. So therefore, in this det value, the one vector is AP bar. What is AP bar? OP minus OA. OP minus OA. What is OP? A bar. Now I can take here, in this, I'll write what is OP bar. OP bar is nothing but R bar. R bar is nothing but X comma Y comma Z. Next, OA bar is equal to A bar is equal to A1 comma A2 comma A3. Now OB bar is equal to B bar. I can write B1 comma B2 comma B3. C bar is the vector. I can write C1I plus C2J plus C3K. I can also write as what? In a point form C2 comma C3. Yes, when OP bar is equal to R bar is equal to Xi plus Yj plus Zk. OA bar is equal to A bar A1I plus A2J plus A3K. OB bar is equal to B bar B1I plus B2J plus B3K. Then C bar is equal to C1I plus C2J plus C3K. Then C1 comma C2 comma C3. Okay. So therefore, that is AP bar OP minus OA, R bar minus A bar, X minus A1 into I, Y minus A2 into Z, Z minus A3 into K. Next, A bar minus B bar, A2 minus B2, AB bar, or OB minus OA, right? B1 minus A1, B2 minus A2, it makes, because since if I write B1 minus A1 or A1 minus B1, A1 minus B1 is also correct because RHS is equal to 0. Since it is what, come on, AB bar, I can also write, this is also correct. Now look here, I can write OB minus OA, I can also write OA minus OB, A1 minus B1, A2 minus B2, A3 minus B3 is also correct because RHS is equal to 0. It is same as B2 minus A2, B3 minus A3. Followed? Next, C bar is the vector parallel to this, C1 comma C2 comma C3. This is the Cartesian equation of a plane passing through how many points? 3 points. So once again, let OA bar is OP bar is equal to R bar, Xi plus Yj plus Zk, OA bar is equal to A bar, A1I plus A2J plus A3K, OB bar is equal to B bar, B1I, B2J, B3K, C bar is equal to C1I plus C2J plus C3K, C1 comma C2 comma C3, C1, C2, C3, right? Now let OA bar is equal to A bar, OB bar is equal to B bar, be the position vectors, and P be any point in the plane, OP bar is equal to R bar. And so from figure, the vectors AB bar, AP bar and C bar are lying in the same plane. For vector equation, one vector can be expressed as linear combination of remaining vectors. For Cartesian equation, they are coplanar. Coplanar means box of AP bar, AB bar, C bar is equal to 0. Box is nothing but a det value, is nothing but OP minus OA, X minus A1, Y minus A2, Z minus A3. AB bar, OB minus OA, B1 minus A1, B2 minus A2, B3 minus A3 is same as B1, A1 minus B1, A2 minus B2, A3 minus B3. Since the vector C bar is parallel, then you can write that is C1, C2, C3. This gives what? The Cartesian equation of a plane passing through 2 points, A bar and a B bar, and parallel to the vector C bar. Yes, students, up to now we come across the two equations of the planes. One is the vector equation of a plane passing through the point A bar, and parallel to two vectors B bar and C bar is given by R bar is equal to A bar plus SB bar plus TC bar. Next, just now we discussed the R vector equation of a plane passing through 2 points and parallel to one vector is R bar is equal to 1 minus S into A bar plus SB bar plus TC bar, and the Cartesian equation of a plane passing through this 2 points and parallel to one vector is this. Now, the another one is, the last one is the vector equation of a plane passing through 3 non-collinear points. Here 2 points. Let us discuss about the Cartesian equation of a plane passing through how many points? 3 non-collinear points, right? Vector equation of a plane passing through the 3 non-collinear points. 3 non-collinear points, A of A bar, B of B bar, C of C bar is R bar is equal to 1 minus S minus T into A bar plus TC bar. R bar is equal to 1 minus S minus T into A bar plus SB bar plus TC bar. What the statement says? The vector equation of a plane passing through 3 non-collinear points, A bar, B bar and C bar. Earlier we have dealt and we have discussed the vector equation of a plane passing through 1 point parallel to 2 vectors. Another one, the vector equation of a plane passing through 2 points parallel to 1 vector. Here it's a passing through 3 non-collinear points. So therefore, now what I do is, this is a plane equation, okay? This is when 3 points are given, to name it, you take, it's about general point P. Now if you want to go for a what? Origin, OB, OA, OP, OA, followed. So therefore, this is like this. Why? To represent them as position vectors. Since you are not given with vectors, you are given with what? Position vectors. You need a origin to represent them as a position vectors. Right. Let us start. The proof of this one is, let OA bar is equal to A bar, OB bar is equal to B bar, OC bar is equal to C bar, and PB any point in the plane which implies when, and OP bar is equal to R bar. Be the position vectors. Position vectors. As I told already, whenever you are given with the points, if you want to prove them as coplanar, you have to construct into vectors. Now we have 4 points, given 3 points, A bar, B bar, C bar, and P is an unknown that we are supposed to find out as a plane equation. OP bar is equal to R bar. Be the 4 position vectors of 4 points. From 4 position vectors, we can construct 3 vectors. They must be co-initial vectors. As I told quite often, co-initial vectors, the vectors which are having the same initial points, are known as co-initial vectors. So therefore, co-initial vectors. Now I am taking from figure AB bar, AC bar, AP bar are lying in the same plane. Are lying in the same plane, which implies vectors AP bar, AB bar, comma AC bar are coplanar. There exists scalars. There exist scalars S comma T such that one vector can be expressed as S into AB bar, T into AC bar. When any 3 vectors are said to be coplanar, one vector can be expressed as linear combination of remaining vectors. Linear combination of remaining vectors. So therefore, what I do is AP bar is equal to S into AB bar plus T into AC bar. But AP bar, AB bar, AC bar vectors are not given, but their position vectors are given. I can write this is OP minus OA S into OB minus OA OC minus OA. Now which implies R bar minus A bar, B bar minus A bar, T into C bar minus A bar. Simplify, you are going to get 1 minus S minus T SB bar plus TC bar. This is nothing but the vector equation of a plane passing through how many points? 3 non-collinear points. A bar, B bar, C bar is given by R bar is equal to 1 minus S minus T into A bar plus SB bar plus TC bar. Once again, let OA bar is equal to what? A bar, OB bar is equal to B bar, OC bar is equal to C bar, and P be any point in the plane, and OP bar is equal to R bar with the position vectors. From figure, the vectors AB bar, AC bar, AP bar are lying in the same plane, which implies the vectors AP bar, AB bar, AC bar are coplanar. When they are coplanar, when they are collinear, there must have scalars. There exists scalars. For coplanarity, 2 scalars. For collinearity, 1 scalar. Now, such S, T, such that one vector can be expressed as linear combination of remaining vectors. Remaining vectors. AP bar is equal to S into AB bar plus T into AC bar. Now, OP minus OA, S into OB minus OA, T into what? OC minus OA. OC minus OA. Now, you simplify this and substitute the corresponding position vectors. Therefore, you are going to get R bar is equal to 1 minus S minus T into A bar plus SB bar plus TC bar. Okay, so therefore, this is the what? Vector equation of plane passing through 3 non-collinear points. Okay, let us discuss about the Cartesian equation of a plane passing through how many points? 3 non-collinear points, A bar, B bar, C bar. A bar, B bar, C bar. Yes, students, let us discuss about the Cartesian equation of a plane passing through 3 non-collinear points. Now, Cartesian equation of a Cartesian equation of a plane passing through the 3 non-collinear points, 3 non-collinear points, A of A bar, B of B bar, C of C bar is det is equal to 0. Now this becomes x minus a1, y minus a2, z minus a3. Next, b1 minus a1, b2 minus a2, b3 minus a3. Next, c1 minus a1, c2 minus a2, c3 minus a3. C3 minus A3. Now if I take a what figure, the same figure I am going to take passing through three non-collinear points, A of A bar, B of B bar, C of C bar. I told you how to construct a what? Coinitial vectors. Why only with AB, AP, AC? Yes, there is no restriction at all. You can also consider AB bar, AP bar, AC bar, or BA bar, BC bar, BP bar, or CA bar, CB bar, CP bar. Not with P, I mean PA, PB, PC. No, it's not valid. So therefore, because A, B, C are given, P you considered to name it as a plane. Therefore, you can go for a what? Coinitial vectors, either AB bar, AC bar, AP bar, BA bar, BC bar, BP bar, CA bar, CB bar, CP bar, not with P. Followed? So therefore, now let us take what is a common proof of this one is, let OA bar is equal to A bar, OB bar is equal to B bar, OC bar is equal to C bar, and OP bar is equal to R bar. Be the position vectors where P be any point in the plane. Now when you have a 4 position vectors from figure, AB bar, AC bar, AP bar, are lying in the same plane. Same plane, which implies or coplanar. There is a one concept, theorem in the multiple product of vectors you come across in the next. When any three vectors are said to be coplanar, I am telling repeatedly, the necessary and sufficient condition for any three vectors to be coplanar is box of AP bar, AB bar, AC bar is equal to 0. Now since the vectors are in terms of IJK, coplanar, I will write coplanar. Since I will write coplanar, I take this one as OA bar is equal to A bar is equal to A1I, A2J, A3K. OB bar is equal to B bar, B1I, B2J, B3K. OC bar is equal to C bar, C1I, C2J, C3K. OP bar is equal to R bar is equal to Xi, Yj plus Zk. xi plus yj plus zk. Followed? Now I can write, when they are coplanar, box of AB bar, AC bar, AP bar is equal to 0. Means box is nothing but a det value. What is AP bar? OP minus OA, x minus A1 into I, plus y minus A2 into J, plus z minus A3 into K. Next, I can write here x minus A1, y minus A2, z minus A3. Followed? Again, yes, come on, AB bar, OB minus OA, B bar minus A bar, B1 minus A1 into I, plus B2 minus A2 into J, plus B3 minus A3 into K. Therefore, you can remove Izk now here. I can write B1 minus A1, B2 minus A2, B3 minus A3. Next, AC bar, OC minus OA, C bar minus A bar, C1 minus A1 into I, plus C2 minus A2 into J, plus C3 minus A3 into K. Now I will write the C is nothing but C1 minus A1, C2 minus A2, C3 minus A3, right? So therefore, now this is nothing but the Cartesian equation of a plane passing through three non-collinear points, A bar, B bar, C bar. Yes. Yes, now look here, the Cartesian equation. Once again, let OA bar is equal to A bar, OB bar is equal to B bar, OC bar is equal to C bar, OP bar is equal to R bar, be the position vectors of a point, where P be a point in the plane, where OA bar is equal to A bar is equal to A1, A2, A3, OP bar is equal to B bar, B1, B2, B3, OC bar is equal to C bar, C1, C2, C3. Yes, come on, OP bar is equal to R bar is equal to X, Y, Z. X, Y, Z. Followed? So therefore, since from figure, the vectors are lying in a same plane, what they are coplanar. When they are coplanar, box of AP bar, AB bar, AC bar is equal to 0. Box is nothing but a what? Determinant value. Right on the determinant. If you expand, you are going to get a what? The plane equation in the form of AX plus BY CZ plus D is equal to 0, right? This is the Cartesian equation of a plane. Students, let us see what type of the vector equation of lines and what planes we discussed about. We discussed about the vector equation of a straight line passing through the point A bar and parallel to the vector B bar is, this is one. Next to the vector equation of a straight line passing through two collinear points A bar and B bar is, R bar is equal to 1 minus S into A bar plus SB bar. Now these two represents the line equations. Next, the vector equation of a plane. The vector equation of a plane passing through one point and parallel to two vectors is R bar is equal to A bar plus SB bar plus TC bar. Next, the vector equation of a plane passing through two points, two non-collinear points. Yes, A bar and B bar is 1 minus S into A bar plus SB bar plus TC bar. A bar and B bar be two non-collinear points. Next comes about the vector equation of a plane passing through three non-collinear points A bar, B bar, C bar. You call it as phi. you call it as what? Phi. Let us see. Now coming to this one is, these two represents line equations. These three represents what? Plane equations. Look here, whenever the vector equations are given in different way, we have to identify them as either line or a plane. What is the basic concept is, sometimes in the examination he gives, what is that? Now R bar is equal to, yes come on, P bar minus 2Q bar plus 3R bar. 3R bar. Instead of P bar and Q bar, you take A bar minus 2B bar plus 3C bar plus S into, yes come on, 4A bar minus 2B bar plus 100C bar. Yes, this represents a dash. Sir, we have only two vectors, A bar and B bar. This is also a vector. Why not it? Sometimes he gives like this. For this, I can write this one as R bar is equal to 1 minus S into, S come on, U bar plus V bar minus W bar plus come on, S into 2U bar plus 3V bar minus 100 W bar, correct? Yes, this also vector, this also vector. Then how do you write? So now for this I go for this one is, how can I write? If I go for R bar is equal to 1 minus S minus T into S A bar minus 90C bar plus S into, yes come on, B bar plus 10A bar, then T into, yes come on, A bar minus 70B bar. Yes, what this represents? Remember, identifying the vector equations as a plane or a what? Line. It does not depend upon the what? Vectors. It purely depends on the what? Scalar, presence of scalars. I mean, the number of scalars. Remember, the perception is left to the student to identify, is it a line equation or a what? Plane equation. For a line equation, you can very well observe when the vector equation comprises only one scalar, then it is a line equation. Look, yes, yes, yes. You say yes, yes, yes. Only one scalar. Therefore, these two represents a what? The vector equation of lines. Now, you can very well observe from the equations 3, 4, 5. What's the difference? Here you have only one scalar. Here you have what? Two scalars. Remember, here the vectors are in different way. That vectors never frames a what? Plane. But what frames a plane? What forms a plane? What represents a plane? Is the number of what? Scalars. When the vector equation comprises two scalars, then it is a plane equation. When the vector equation comprises only one scalar, it's a line equation. Students, one scalar, line. Two scalars, plane equation. So therefore, hereafter, one must have what? Idea about how to represent the what? Equation of a line or equation of plane. The number of scalars gives the what? Either line or a plane. One scalar, line. Two scalars, plane equations. Yes, students, we came to understand now which is the vector equation of a line and which is the vector equation of a plane. Yes. Let us see under different context, under the different situation, how to elaborate, is it a line equation or a what? Plane equation. Followed? Yes. Now students, As we come across the different equation of straight lines, vector equation of straight lines and vector equation of planes, under that discussion, we have these are the following questionnaires. These are concept oriented questions. One must have the good idea about what vector equation of straight lines and what planes equations. So therefore, what I do is, if A bar comma B bar are two non-collinear vectors, then R bar is equal to SA bar plus what? TB bar represents a dash. You can very well observe, as I told just now, whenever the vector equation comprises two scalars, it's a plane equation until and unless he changes its argument. What, sir? Means he told R bar is equal to SA bar plus TB bar represents a line. He has to what? Tell, he has to prove, he has to say, he has to give in the what command data. He is saying that I told just now two scalars, plane equation, but he says line equation. It is not our risk. Okay, when he says line, we have to consider it's a line. So if it doesn't say anything, it is always taken as plane equation when it contains the two scalars. Followed? So therefore, now if A bar comma B bar are two non-collinear vectors, then R bar is equal to SA bar plus TB bar represents a dash. Certainly it's a plane equation. Certainly I go for what? It's a plane. It is not a line, but it's a plane. It can be C. So then what it represents? So therefore actually there are what? Three types of planes equations. One is, if I go for this, if one is R bar is equal to, this is a vector equation of a plane passing through the point A bar and parallel to vector what? B bar and C bar. But in place of B bar, you have A bar. In place of C bar, you have B bar. But in place of A bar, origin is there. For plane compulsory what? Three vectors must be needed. So therefore, in place of A bar, you have a what? Origin. So therefore, this represents a what? You can take this one also. R bar is equal to 1 minus S into A bar plus SB bar plus TC bar. Yes, in place of A bar origin into this origin. Now this plane becomes this plane. Why here also origin, here also origin. I can also write the another equation of a line, vector equation of a plane passing through three non-collinear points A bar, B bar, C bar is 1 minus S minus T into A bar plus SB bar plus TC bar. When A bar is equal to 0, total this value becomes 0, this also 0, this also 0. All the three planes will become as R bar is equal to SB bar plus TC bar. It means that one vector can be expressed as linear combination of what? Remaining vectors. Why? Non-collinear vectors. Just like a B bar and C bar. Here B bar and C bar. These are the vectors. So therefore, if you take into 1 minus S into A bar, it is in place of A bar is a point. This is a vector equation of a plane passing through the point A bar and parallel to vector two vectors. This point A bar is nothing but an origin. Certainly, this represents a plane passing through origin. So therefore, for this, option C is correct. This is a conceptual. Okay, concept oriented questions, these are all. Then if I come to second one, if R bar is equal to SA bar plus TB bar represents a line passing through the points A bar and B bar. It is passing through how many points? 2 points. Therefore, you take this question as 1. Now, for this, I am going to write the solution is, we know that, don't repeat the same scalars, we know that vector equation of a straight line passing through through the points A bar comma B bar is R bar is equal to 1 minus x into A bar plus yb bar. You call it as 2. Means he says this is the line. He says this is also line by definition. This is given as a line. When this is given line, this must represent a what? R bar is equal to 1 minus x into A bar plus yb bar. You take xb bar instead of this. Okay, same scalar. So therefore now from 1 and 2, 1 and 2 must represent same. Represent same. So therefore, now you compare the coefficients. 1 minus x is equal to s, x is equal to t. So therefore, add up, which implies if you add these two, 1 minus x plus x is equal to s plus t. These two get cancels. We have arrived at s plus t is equal to 1. So therefore, option is third option. It's a third option, right? Then coming to now question number 3. The vector equation of a plane passing through the points A bar, B bar, C bar. He has given this. But the vector equation of plane is this only, correct? You call it as what? Come on. 3. You call it as 3. Now, for this equation of a plane, equation of plane passing through the points A bar, B bar, C bar, he has given here, is R bar is equal to, don't use the same scalars, A bar, SB bar, TC bar, you call it as 4. Since 3, 4 represents same. Therefore, compare the coefficients. 1 minus s minus t is equal to alpha. Next, s is equal to beta and t is equal to gamma. Add up 1 minus s minus t plus s plus t, alpha plus beta plus gamma. This and this get cancels. Therefore, I can write alpha plus beta plus gamma. These are the different situations you come across under the vector equation of a straight line and vector equation of a plane. Yes, students, we come across what? The vector equation of straight lines, 2 vector equation of straight lines. 1, the vector equation of a straight line passing through the point A bar and parallel to vector B bar is what? R bar is equal to A bar plus SB bar. The next, the vector equation of a straight line passing through what? 2 collinear points R bar is equal to 1 minus S into A bar plus SB bar. These two are what? Line equations. If there is one scalar, it's a line equation. Next we come across its Cartesian forms. Its Cartesian forms are A bar is equal to A1i A2j A3k, B bar is equal to B1i plus B2j plus B3k, R bar is equal to xi plus yj plus zk. The Cartesian forms of a straight line passing to the point A bar and parallel to vector B bar is x minus A1 by B1 is equal to y minus A2 by B2 is equal to z minus A3 by B3. Next, the Cartesian forms of a straight line passing to the 2 points A bar and B bar is x minus A1 by B1 minus A1, y minus A2 by B2 minus A2, z minus A3 by B3 minus A3. Next, the vector equation of a plane passing through one point A bar parallel to 2 vectors B bar and C bar is what? R bar is equal to A bar plus SB bar plus TC bar. The Cartesian equation of a plane passing through the point A bar and parallel to vectors B bar and C bar is determinant x minus A1, y minus A2, z minus A3. Next, B1, B2, B3, det, B3, next C1, C2, C3. Similarly, the vector equation of plane is passing through 2 points R bar is parallel to one vector, R bar is equal to 1 minus S into A bar plus SB bar plus TC bar. Similarly, you can find out Cartesian equation of a plane. We found out. Then this represents a vector equation of plane passing through 3 non-collinear points. Is A bar, B bar, C bar is R bar is equal to 1 minus S minus T into A bar plus SB bar plus TC bar. Thank you.